Okay, for 1993 AB1, we have the function f of x is equal to x cubed minus 5x squared plus 3x plus k, where k is a constant. We want to find out on what intervals f is increasing. And stated most simply, f of x increases when f prime of x is greater than 0. So the first thing we're going to do is find the derivative of f, set it equal to 0, do a sign test, and find out on which intervals the derivative is positive. So the derivative is 3x squared minus 10x plus 3. We're going to set that equal to 0, and we need to factor that, so I'm going to multiply the 3 to two threes. That gives me 9, and I'm looking for two numbers that multiply to give positive 9 and add to give negative 10. And those two numbers would have to be negative 9 and negative 1. So I'm going to rewrite the original expression and replacing the negative 10x with negative 9x minus 1x. And I'm going to use factor by grouping. That gives me 3x times x minus 3 minus the quantity x minus 3, and that's equal to 0. And so finally I get 3x minus 1 times x minus 3. And that will be equal to 0 when x is 1/3 or x is 3. So those are the places where f prime of x is equal to 0. If I want to find out where f prime of x is greater than 0 or positive, I'm going to make a number line, record my zeros, find test values for each of the three intervals created, so I can use 0, 1, and 4. And remember, what I'm trying to do here is to find out where f prime of x is greater than 0. And so I'm going to test these values back into f prime of x. So it's best for me often to use the factored form of f prime of x, and that's 3x minus 1 times x minus 3. When I plug in 0, I get negative 1 times negative 3, which is positive. When I plug in 1, I get 3 minus 1, which is 2, 1 minus 3, which is negative 2. So that gives me a 2 times negative 2 is negative. And finally, when I substitute 4, I get positive, and positive times positive is positive. So from here I can see the intervals on which f is increasing, and that will be from negative infinity, recalling that f increases when f prime of x is positive. So from negative infinity to positive 1/3, or from 3 to positive infinity. And so that's the answer for part A. Part B asks on what intervals is the graph of f concave down. And so f is concave down when f prime prime of x, or the second derivative, is negative. And so for this we're going to need to find the second derivative. To find the second derivative, we don't use the factored form. We're going to go back to the original, most simple form of the first derivative. And in this case, that is 3x squared minus 10x plus 3. And so the second derivative is 6x minus 10. And if we want to find out where that is negative, we first find out where it's 0, and then we do a sign test on either side of the zeros. In this case, there's only one 0, and that's going to occur at x equals 5/3. We do a sign test on x equals 5/3, choose a test value of 0 and 2, and recall we want to find out where the second derivative is negative, so we're going to substitute those values into the second derivative and see what sign we get. Plugging in 0, I get negative. Plugging in 2, I get positive. And so we can say then that f is concave down on the interval between 5/3 and positive infinity. And we'll go on to part C in the next video.